Hello students, in today's class we will start a new chapter that is gravitation. It's a common experience that everything when released in the free space falls towards the earth. It appears that earth attracts everything towards it. As we all know, Newton observed that an apple falling downwards towards the earth after it was separated from the tree. After conducting the logical reasoning, Newton arrived at an idea that Earth attracts everything towards its center. Also, he concluded that there is a force of attraction between any two bodies in the universe. So in today's class, we will study the Newton's universal law of gravitation and let us define the unit mass and will derive the expression for acceleration due to gravity at an altitude that is height h. Let's begin. Let's state the Newton's universal law of gravitation. It states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let's write it mathematically. Let us consider the two bodies of mass m1 and m2 as you can see in the diagram. They are separated by the distance r and F be the force of attraction between the two bodies. So we can write it as F is directly proportional to the product of their mass. We can write it as m1, m2 and F is inversely proportional to the square of the distance between them. So we can write it as F is proportional to 1 by r square, that is inversely proportional. Next, we can write it as F is equal to G, capital G, m1, m2 by r square, where this G is a gravitational constant. We can write the value of the gravitational constant like it has a value that is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Let's define the unit mass. According to the Newton's law of gravitation, the magnitude of attractive force F between the two bodies of masses m1 and m2 separated by a distance r is given by, as we have learned previously, F is equal to G m1 m2 by r square. Now, considering the value of m1 m2 is equal to 1 and r is equal to 1 and G is 6.67 into 10 raised to minus 11, then what happens to F is equal to 6.67 into 10 raised to minus 11 Newton. So the unit mass is that mass which when placed at a distance of 1 meter from a similar mass experiences an attractive force of 6.67 into 10 raised to minus 11. Let's derive an expression for acceleration due to gravity at an altitude height that is h. So let's consider a body of mass m, that is small m, at a height h above the surface of the earth, which is having a mass m, that is earth having a mass, we'll consider it as capital M, and radius we'll consider it as r, as you can see in the diagram. Now, the gravitational force we can write between the earth and the body as F is equal to capital G, capital M, small m divided by R plus H whole square. The capital G is the gravitational constant and capital M is the mass of the earth and small m is the mass of the body. Now, the weight of the body, we can write it as F is equal to mgh, where g is small. Now we'll consider this as equation 2 and the previous equation as 1. Now from equation 1 and 2, we'll write it as mgh, that is small gh, will take f value. Mgh is equal to capital G, capital M, small m divided by r plus h whole square. Now cancelling m on the both sides, small m on the both sides, what we can write it as gh, small gh is equal to capital Gm divided by r plus h whole square. We'll consider this as equation 3. Now the acceleration due to gravity on the surface of the earth, we can write it as small g is equal to capital Gm divided by r square. We'll consider this as equation 4. Now dividing the equation 3 and 4, what happens? 3 is small gh and 4 is simply g. So gh by g we can write it as equal to r square by r plus h whole square, where capital G and capital M get cancels. So simply what we get it as r square by r plus h whole square. Now taking the small g to this side, what happens? Gh, that is altitude, height, gh is equal to g r square by r plus h the whole square. We consider this as equation 5. So this gives the expression for acceleration due to gravity at an altitude h. So next, the acceleration due to gravity at a small height, that is the acceleration due to gravity at the height h above the surface of the earth of radius r, we can write it as, we have derived it, gh is equal to g r square by r plus h the whole square. Next is that we can write the equation as gh is equal to g r square by r square plus, we can write it as r square plus 1 plus h by r the whole square. Okay, r square get cancels. So we can write the equation as gh is equal to g by 1 plus h by r the whole square. Again we can write the equation as gh is equal to g in the bracket of 1 plus h by r whole minus 2. Okay, if h is less than r, then we can write it as gh is equal to g in the bracket of 1 minus 2h by r plus terms containing the higher power of h by r. So we can write it as 1 minus 2h by r. So the equation becomes gh is equal to g in the bracket of 1 minus 2h by r. So this gives the expression for acceleration due to gravity at a small height where h is less than r. So in the next class, we will derive the expression for acceleration due to gravity at the depth d. Thank you.